So let's have a think about this. So what I'm going to do is I want you with me to draw this frequency table down. So we are literally going to collect some data as a class, which is going to be the number of siblings which somebody has. So siblings are brothers and sisters, okay? So we're going to create a table, and this will be frequency. So can you copy this down with me? What have I done? 6, 7, and then 7 plus. Good. Okay, so what I want you to do is I want you to, when I call out a number, I want you to stick your hand up if you have this many number of siblings. So for example, I have 1 sibling, so I'm going to stick my hand up if I call out the number 1. Okay? Are we all happy with what a sibling is? Yeah, it's numbers of brothers or sisters. Okay? So who in here have no brothers or sisters? 1, 2, 3, 4 people. 4 people, yeah? Or 5 people? 6. Okay. 5 people, is that right? So do it again. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So there's 8 people in here with no brothers and sisters. Okay. Who in here has 1 brother or sister? So 1, 2, 3, 4. Okay. Who in here has 2 brothers or sisters? So put your hands down. Who in here has 2 brothers or sisters? Just 1 person. Who in here has 3? Just the 1. Who in here has 4? 5? 4. Anybody not put their hand up yet? No? Okay, so I can put zeros in all the other ones. Perfect. Okay. So what I've drawn here is what's known as a frequency distribution. What does the word frequency mean? The number of times that something occurs. I did hear it. It's over there and over there. It's the number of times that a value occurs. Number of times that value occurs. Okay. Now what I want to do is think about this instead of as a frequency distribution. So frequency distribution. What I want to think about is this as a probability distribution. So how do you think I'm going to convert this into a probability distribution? By the way, probability distribution now says, imagine somebody was going to walk through that door and just pick one of you at random. Okay? What is the probability that you have 0 siblings? Or what's the probability you have 1 sibling? Or what's the probability you have 2 siblings? How do you think I'm going to convert this into a probability distribution? How could I do that? Any suggestions? Okay, so you need to think first of all about the total number of people we've got in the class. So what's the total number of people that we've got in the class? How could you work that out from this table? How do you get that? You literally just adding all the frequencies together. Yeah, so is that 15? Yeah, good. And then all you need to do to work out the probability that you select somebody with no siblings is to take the number of people with no siblings, which is 8, and divide it by the total, which is 15. Okay? So can you, for me, create this new table, which is same kind of thing, but just exchange frequency for probability? Can I give you 2 minutes to have a go at that for me? Okay, so can I just ask you then to read out the probabilities for each of the different number of siblings? Yeah? So what's the probability that we select somebody with no siblings? 53%? Good. Okay. What's the probability we select somebody with 1 sibling? So what was it? 20? Yeah, round it to 27%. That's fine. Okay. What's the probability we select somebody with 2 siblings? 7%. What's the probability we select somebody with 3 siblings? Should be the same. Okay. What's the probability we select somebody with no siblings? 4 siblings? 0%, because there's nobody in here with no siblings. Okay. Probability we select somebody with 5 siblings? 7%. And what are all the other probabilities going to be? 0. Good. So 0%, 0%, and 0%. Okay. So does that make sense what a probability distribution is? This is a probability distribution here. Boys, you paying attention? Good. Are you happy with what a probability distribution now is? Okay, so it's literally just a way of writing what is the probability of selecting somebody with this many siblings. So 2 siblings or 3 siblings or 4 siblings. Yeah? Are there any questions about what we've done there? Is it all clear? Because if you understand this, the rest is easy. Yeah? Probability distribution, all it is just a way of showing what is the probability of each outcome occurring.
Or the answer has to be rounded?
It's a good question. Okay, so you see here we rounded the probabilities to 1%, so the nearest 1%. Okay, strictly speaking, you should be as accurate as you possibly can, but sometimes these numbers go on forever and ever and ever, so you can leave it to as many decimal places as you like. So I think choosing it to 1%, that's totally fine in this case. So sometimes you have to decide what degree of accuracy you want. Okay, but 1% in this case is fine. Now here's a question. What should all of these probabilities have to add up to? Yeah. So in this case, 100%, but yeah, absolutely 1. Okay. Remember, 100% literally represents certainty. Okay. So if you select everybody in the room, if you select any one of these people in the room, you know that probability has to add up to 100 because you've got to select people. Does that make sense? Yeah. Good. Fantastic. So using that then, could you have a go at those 4 questions on the board for me? So what's the probability of choosing somebody with 2 siblings? What's the probability of choosing somebody with fewer than 3 siblings, more than 6 siblings, between 3 and 6 siblings? Okay, so let's talk through these questions. So what do we get? What do we get for question 1? So what is the probability of choosing somebody with 2 siblings? 7%, perfect. We can just literally read it off from the table. Okay. What about question 2? What's the probability of choosing somebody with fewer than 3 siblings? Good. So fewer than 3 siblings would be 0 siblings, so 53%, or 1 sibling, which is 27%, or 2 siblings, which is 7%. So what are you going to do to these 3 probabilities? Add them together. Perfect. Yeah. Good. What about the probability of choosing somebody with more than 6 siblings? 0, yeah, because it could be 7 or 7 or more. Add those probabilities together, we still get 0. Good. Now here's a question. What's the probability of choosing somebody who has a sibling, or the number of siblings, between 3 and 6? 13.33. Right, so it's about 14%. So between 3 and 6, It's interesting you say 14%, because if you say 14%, so between 3 and 6 siblings would be this, right? Yeah. So surely we should just add together these probabilities and get 14%. I agree. But why is this question confusing? Why is this question ambiguous? It means it's open to interpretation. Exactly, yeah? All I've said to you, and I'm using language here, is between 3 and 6. So does that mean we include the 3? Does that mean we include the 6? Or is it, strictly speaking, just between 3 and 6, not including those, so just 4 or 5? Does that make sense? Yeah? So actually, when we start using language with probability, it gets confusing. But that's okay, because we're mathematicians. Like, we can write this much, much clearer using notation. So have a look at the screen for me.